Here we're going to try a challenging application of cyclohexane rings. It turns out that glucose, C6H12O6, can form rings, and these rings form in chair conformations for the most part. The only difference being that one of the members of your 6-carbon ring is that oxygen. But we can use the same principles we learned about the chair. So we're going to try to draw both chair conformations for glucose, and here I've shown the stereochemistry where some of the groups off of the ring are up and some are down. So first, we'll start by just drawing a chair, and we begin with 2 offset parallel lines. Head of the chair goes up, foot of the chair goes down. Then one of these corners is an oxygen, and that's the main thing that's different about glucose versus cyclohexane rings. On the chair, instead of just up and down, we have axial and equatorial positions, so we'll try to draw those. Remember that at the head of the chair, axial is always up, and then it alternates down, up, down. The foot of the chair is always down. The oxygen has lone pairs, so it doesn't have groups sticking off. But again, if the head of the chair is up, this position would be down for axial. That's the axial positions. We could also draw the equatorial positions, and it doesn't matter too much as long as they're not vertical, but it helps to point them out where there's open space. Equatorial, 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 and equatorial. Again, the oxygen has a couple lone pairs on it, so we don't draw any bonds there. So now we look at each one of these groups, and let's say to the right of the oxygen is carbon number 1, and so this is carbon number 1. The OH is definitely pointing up. So on the ring, the axial is clearly down, so by default, the equatorial is up, so that's going to be our OH group. As we move on to the next carbon over, which will be this carbon here, the OH is clearly pointing down. If axial is clearly up, by default equatorial is down. I tack on my OH there. Moving over to the next carbon, the OH is clearly pointing up. If axial is down, equatorial must be up. Go to the next carbon up, over, and it is clearly pointing down. If axial is up, equatorial must be down. And then finally, moving to this carbon, the group there is clearly pointing up. And so if axial is down, equatorial must be up, CH2OH. And then we could show the hydrogens, or we could just delete off these bonds. So again, I could show H, 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 or I could just get rid of those altogether, and it could look something like this. Now, that's one of the chair conformations. If I were to do a ring flip, all of these axial and equatorial positions would reverse, and when we do a ring flip, the head of the chair rotates down, and the foot of the chair rotates up. So I draw my offset parallel lines. The left used to be pointing up. Now the left is pointing down. The right side used to be down the foot. Now the right side is going to be the head of the chair. And we can't forget our oxygen, which used to be here and is still on that corner. So now all of these groups that used to be equatorial, 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 are going to become axial. So This OH used to be equatorial. Now it's axial. The head of the chair always points up for the equatorial spot. This carbon used to be equatorial. Now it's axial. And that's going to alternate up, down. Now we move over, used to be equatorial. Now axial. Again, up, down, up. The foot of the chair was right here. The foot of the chair should be pointing down. And then finally, this used to be equatorial. Now that is going to be axial over there. So we could have them all in axial positions or all in equatorial positions. And the reason why biologically that matters is when you go to form a polysaccharide, when this ring fuses with a bunch of other rings, whether that group is axial versus equatorial will have big difference in whether you're able to use this in your body. For example, starch versus cellulose. You can digest starch, you cannot digest cellulose, and it has to do with whether that bond is axial or equatorial, and it really, again, has a big difference.